This is video number 3 in the volume using the disk method. In this video I'm going to show you how to find the volume of a region in which we revolve about any horizontal or any vertical axis. Okay, so in this example we have y equals 2x, y equals 6, and x equals 0. That area is going to be revolved about the line y equals 6. Okay, so I'm going to go ahead and sketch the region that will be revolving. Okay, so first thing I'm going to do, I'm going to go ahead and sketch where my axis is. So right here where y is equal to 6, that's where we're going to be doing our revolving. Alright, we have the equation y equals 2x, so that's just a line. And y is equal to 2x, we have an intersection here when x is equal to 3. The line y equals 6, so the actual axis is also a boundary. And then x equal to 0, our y-axis is our third boundary. So the area in question is this triangle right here. Okay, so now we're going to revolve this. And we're going to get something that looks like a cone. Okay, so when we go to set up our volume problem, remember you always set everything up by looking at the original shaded area. So I'm going to go ahead and sketch in a cross section. And my cross sections again will be a disc. Oops, do that the other way. So there's my cross section. Give it a little bit of thickness. Okay, so off of that cross section I can see that the height of each of these discs, or how thick each cross section is, those lie along the x-axis this time. So dx, this is going to be a dx problem because the height of each of these discs is a dx. We're also going to need to know what is the radius. So when I go to measure my radius, you want to measure from the center of your figure out to the outside. So there is my radius. And you'll notice here that our radius is actually going to come from the original area problem. So when I go to measure my radius, I want to measure from this point here down to this point here, which was basically the same thing as what we did when we found the height of each of the rectangles in the area problem. Okay, so to get our radius, we really want just y top minus y bottom. Okay, so for y top minus y bottom, y top in this case is this straight line. Okay, so that was the line y equals 6. So y top is just y equals 6. Minus y bottom is the line y equals 2x. So I say minus y bottom, y equals 2x. Okay, so that tells me that my radius is going to be equal to 6 minus 2x. Okay, so now I can go ahead and set up my volume equation. So volume, again, remember, is just the volume of a cylinder, so pi r squared times height. And we're going to sum all of those up. Pi comes out front because it's a constant. We're summing up our height squared, so we need 6 minus 2x squared, and then times the height of each of our cross sections, which was dx. Okay, the only thing we're missing is our limits of integration. So as you take these cross sections, you are going to be stacking those here along the x-axis, so we need the limits of integration to be in terms of x. Our x values start at x equal to 0, and they go up to x equals 3. Okay, and that's going to give you then the equation for volume. And again, as we did in the previous two examples, I'll let you guys go ahead, do the expanding and then the integrating and evaluating. When you check your answer, you should get 36 pi. Okay, so then our final example, we are going to do a similar problem, but this time we're going to revolve around the line x equals 2. So now we have a vertical axis. Okay, the area is going to be bounded by y equals x squared, x equals 2, and y equals 0. So let's go ahead and get a sketch of our solid. This time our axis is at x equals 2, so I'm going to go ahead and sketch that in. So x equals 2. Here's our axis. The area in question, we have a parabola, so y equals x squared. That's just going to be parabola from the origin, opening up. We have x equals 2. The actual axis, again, is a boundary. And then y equals 0, the x-axis is our third boundary. So the area in question is this piece right here. I'm going to go ahead and label this point up here. This is 2, 4. Okay, so now we're going to revolve this about our line x equals 2. So we're revolving this direction. I'm going to go ahead and sketch the rest of my solid, so it'll look symmetric on the other side and looks something like a Hershey Kiss. Okay, so now looking at this solid, we want to go ahead and locate our cross sections. So when I sketch in the cross section here, I've got this disc. Okay, now when I look to see, okay, how tall or how thick is each cross section, those are being measured along the y values. Right, so from top to bottom, that is a dy for our height of our cylinder or height of our disc. We also need to know what is the radius. So remember, radius we can measure from center to the outside. So here is our line for our radius. And radius this time is a length in terms of x, or a length that is an x value, rather. So we want to take the value of x on the right side, and we want to subtract the value of x on the left side to measure that length. So we want x right minus x left for our radius. Okay, so now plugging in for our radius, x right, that's going to be x equals 2. It's always going to be x equals 2. X left is going to be the value from this parabola. So we want to take the equation from the parabola and we want to solve that for x. So doing that, we get square root of y. Okay, so our radius for this particular problem is 2 minus the square root of y. Okay, so now we can go ahead and set up our integral. Remember, volume is equal to pi r squared times the height for a cylinder, which is the same as our disk, and we want to sum those up. So we're going to take an integral, take the pi out to the front. We need the radius squared, so 2 minus the square root of y squared times the height or the thickness for each of our disks, which is dy. And since we are integrating with respect to y, we are stacking our disks up here along the y-axis, so that means we are integrating along the y values. So our lower boundary for y's, we start here at y equals 0, and we go up to y equals 4. Okay, so there is our integral setup. Again, I'm going to have you guys go ahead, multiply that out, integrate it, evaluate it, and then I'd like you to show me your answer tomorrow when you come to class. Okay, so tomorrow when you guys come, we will be working on these types of problems in class. I will be there to assist you. The next topic that you'll be watching about the next night will be similar problems, but we'll be doing a washer method. So I will see you tomorrow.